All right, welcome back. Let's do some examples. Here we go. So we've been talking about polyatomic ions, and for our next adventure, we are going to stick two ions together. So just like ions from last quarter, you're always going to have some sort of positive charge, some sort of cation, sticking to some sort of anion, some sort of negative charge. Just to like plant that in your brains, you already knew that, but and your other keys here are going to be the charge of each of your ions, and you know that since we can't have like charge buildup, all compounds will always be neutral. Compounds are neutral. Okay. I'm going to show you your example question document, and then we'll load it up right here. If you happen to have the packet, you are looking at page 11 and page 12. So I'll show you that also. But so off we go. Here's page 11. And page 12. And I actually recorded this whole thing and it didn't save, so you're going to see some stuff written on these also from last time, including your homework. So we'll get to that in a second. I'll teach you how to do it first, right? Great. Okay, so on this side, you're going from the name of a compound to its formula. Try this again. Sorry. There's its formula. You are going to write its name. And on this other side, you get the name, and you are going to write the formula. Once we're done, you'll choose 5 on both sides. And that's what you're going to do for today. Let's figure out how to do it first. Okay, so we're going to start on this side where you're given the formula and you're going to write the name. Let's start with that first one. So you've got NH4Cl is your first one here. Okay, so half of your battle with these is figuring out what your two ions are. In this case, how to figure out what your two ions are. Part of it is that you're just going to stare at your polyatomics an uncomfortable amount over the next couple days. You're kind of going to start to get the hang of it. Aside from that, I don't kind of on your own. There's a list of handy-dandy polyatomics on the top of this page. You can use these too, obviously. And at some point, you're going to start to see stuff like that is polyatomic right there, and that is not. So there's your polyatomic. Parentheses are also kind of a helpful hint. If it has parentheses, in this case, it is a polyatomic. Okay, found your polyatomic. You know that it's positive because it's in the front, so it's got to be positive. There's your polyatomic page. I'm also going to make this go a little faster because I think maybe it didn't save because I was too slow. So I'm gonna give you some of this stuff and zip you through it. So there's your NH4 over there. And according to your handy-dandy polyatomic ions page, which you can have forever and ever, it will never take this away from you, just like your periodic table. It's got a charge of +1. There's your charge of +1. And your chloride is a monatomic ion, so instead of being on this polyatomic side, monatomic stuff, anything that is a single atom ion will be found on your periodic table. And there you go, there's your chloride. Chloride will always and forever have a charge of -1, as will every other halogen. So you've got ammonium that has a charge of +1, a chloride that has a charge of -1, and it works. That's actually neutral right there. You've got +1, -1, that is a neutral compound. Here we're looking for its name, so let's find that NH4 had the name ammonium, so we're going to write down ammonium. And that chloride, that Cl is a chloride. It is a monatomic ion over on this side. Monatomic ions always have the same ending, always and always. Monatomic ions end in, this was last quarter. When I forget, I think about sodium chloride, which is table salt. Monatomic ions always end in "ide." Okay, so we've got a single chlorine here that is in its ion form. That's a chloride. That just shows you that there's a single atom ion, a monatomic ion, instead of a polyatomic ion. All right, that's your ammonium chloride. Let's pull number 6, and then I'm going to break this into 2 recordings just to, yeah. So we're going to pull number 6 next, and 6 is gross. I chose this one because it looks weird. There's all these numbers in it and this SR, like who is SR anyways? Again, first step, break it into your polyatomic. We had a nice hint here. There's parentheses here. You can even kind of think of the parentheses as being like a circle, kind of like polyatomic ions always live in circles. Yeah, that's your polyatomic, and your SR is a single atom, only one capital letter, single atom. It's somewhere over here on the positive side of your table. That is your strontium. It's in your second column. It will always have charge of +2, always and always. So your strontium has charge of +2 and a name of strontium. Okay. And then you've got your polyatomic. Polyatomics are over here on this side. I'm going to give you this. There is your PO4, which is what you're looking for. All right, so your PO4 has a charge of 3-. You know these charges are your key. Okay. Right, so we're going to keep track of them. Okay, so your PO4 3- has a name of phosphate. We'll just write that there. And that is the name of that compound. I'm going to show you some more stuff with this charge, but I'm going to do it in a second video. But again, on this side, you're choosing any 5. You can type these into the Google Doc that I'm going to share with you, or you can write them on paper. Either way is totally fine. We'll be back in a hot second for this side.